Hello everyone, welcome to my new video. My name is Zoran, and I am Cloud Solutions Architect. In the previous videos in this series, I showed how to build different capability layers of an enterprise AI architecture. First, I showed how AI can use HyperRAG to retrieve knowledge from complex enterprise documents, policies, procedures, and technical content. Then I showed how MCP can allow an AI system to interact with tools, services, and APIs in a controlled way. After that, I covered Text-to-SQL, where AI can answer business questions by using structured data from databases. So at this point, we had a strong foundation, an AI system that can read documents, use tools, and query databases. But in real enterprise environments, there is one more important layer that is often overlooked. And that layer is visual information. Real business documents are not always just text. Very often, PDF files contain photos, diagrams, charts, tables, scanned reports, equipment pictures, field inspection images, or screenshots from business systems. For example, someone may ask, is this site ready to continue normal operation? The answer may not be written directly in the text. The report may only say that an attached image needs to be reviewed. But the real evidence may be in the image itself. Standing water around equipment, a blocked warehouse path, visible damage, a leaking connector, or another operational risk. If the AI system only reads text, it can miss a major part of the business context. And in many business situations, that missing visual evidence can be the difference between a useful answer and a completely wrong conclusion. That is why, in this video, I am adding the missing link from the previous parts of the series, multimodal document RAG. The goal is to show how an AI system can use not only text from PDF documents, but also images inside those documents. In this project, I use several PDF files that simulate real business scenarios. The dataset includes 4 sample business documents with pictures in: a field site readiness report, a warehouse safety report, an equipment condition report, and an operations performance report with text and table data. This gives me a controlled dataset. 3 documents test multimodal retrieval because they include important visual evidence, while the 4th document provides a regular text and table baseline. So I can compare standard RAG with multimodal document RAG. For this demo, I start with Azure Storage, where the original PDF documents are stored in a private blob container. In a real enterprise implementation, the same process could start from many different data sources, such as SharePoint, OneDrive, file shares, document management systems, application exports, or any other system where business documents already exist. Then Azure AI Search connects to that container through a data source and runs the indexing pipeline. In this project, I decided to use Azure AI Search because it fits naturally into the Azure architecture. It gives me a managed indexing pipeline, skill sets, vector search, and integration with AI models. But the principle is not limited to Azure AI Search. The same architecture can be implemented with a custom indexing pipeline. For example, a Python process, an OCR or vision model, an embedding model, and a vector database such as Postgres with pgvector, Quadrant, Pinecone, Viviat, Elasticsearch, or OpenSearch. The important idea is not the specific tool. The important idea is the process. Documents must first be prepared for retrieval. Text is extracted. Images are extracted. Images are described by an AI model. Embeddings and metadata are stored in a retrieval index. Only after that does the runtime model use those prepared records to answer a user question. In my implementation, Azure AI Search runs a retrieval preparation pipeline. The document extraction skill extracts text and images from the PDF files. The split skill divides extracted text into searchable chunks. The chat completion skill, also called the GenAI prompt skill, sends each extracted image to an AI model. That model generates a business-focused description of the image. The prompt I send to the model for each image is intentionally simple and factual. You are analyzing a business document image. Describe what you see in terms of operational conditions, safety risks, equipment state, or any visible anomalies. Be specific and factual.
That same prompt is used for every extracted image in the pipeline. This means the quality of the generated image description depends heavily on the prompt design, the image quality, and the model's ability to interpret the visual evidence. After that, the Vision Vectorize skill creates embeddings for the text and image-related content. The Shaper skill prepares metadata and paths, and Index Projections write the final records into the Azure AI Search Index. The key point is this. The runtime model is not looking at the raw PDF and guessing what is inside the image. The image is processed earlier during indexing. The image is extracted, described by an AI model, embedded, and stored as retrieval-ready grounding data. In the Azure AI Search Index, I now have fields such as document title, content text, content embedding, content path, location metadata, and image description. The content text field contains regular text chunks from the document. The image description field contains the AI-generated description of an extracted image. The content embedding field supports vector retrieval. The content path field exists for image records and points to the extracted image artifact. And location metadata can hold page or location information when the pipeline provides it. This is the point where textual and visual content become retrieval ready. In this index, text chunks and image records are stored separately. For example, if a PDF page contains text and also an extracted image, the text becomes one searchable record, and the image description becomes another searchable record. Both records keep document-level metadata, such as the source document, title, and page or location metadata when available. That is important because at runtime the model is not reading the original PDF directly. It receives retrieval-ready grounding records from Azure AI Search. Once the documents are indexed, we move to the runtime part of the application. The user asks a question in the web UI. The web UI sends that question to the demo API. The demo API sends a hybrid retrieval request to Azure AI Search. When I say hybrid retrieval, I mean that Azure AI Search combines keyword search with vector similarity search. The keyword search helps find exact business terms from the documents. The vector search helps find semantically related content based on embeddings. More specifically, Azure AI Search can combine BM25 keyword search with vector similarity search and merge the results into a single ranked list using reciprocal rank fusion. The result is one set of grounding records that combines lexical and semantic relevance. The demo API then selects the primary document, filters the results, prepares a structured grounding context, and sends that context to the model. That context includes the user question and the evidence returned from Azure AI Search. The model receives information such as which document was used, whether the evidence came from text or image, and what the evidence actually says. So the model is not answering from memory, it is answering from retrieved grounding records. In the web UI, I show three main sections. The first section is the question and answer. The second section is citations and grounding. This shows the evidence returned from the retrieval process. The third section is trace. The trace shows the observable flow. The question is received. Azure AI Search hybrid retrieval is executed. The primary document is selected. Grounding records are prepared, and the model answer is returned to the UI. The goal is not just to have the model say yes or no. The goal is to show why the model reached that conclusion. Now I can test the system with real business questions. The first question is the field site ready to continue normal operation? The system finds the field site readiness report. It uses the text policy section, but it also uses the image description showing standing water around industrial equipment. The answer explains that the site is not ready for normal operation, and that the conclusion is supported by both text evidence and image evidence. The second question is there a safety risk that requires immediate intervention in the warehouse? Here, the system uses the warehouse safety report. The visual evidence comes from the image description. The description identifies restricted access and a possible obstruction or egress risk. The model then provides a business answer and recommends immediate intervention. The third question is, can the equipment condition cause a service interruption? In this case, the system uses the equipment condition report. The image description shows a leaking hose or connection with visible residue and signs of a possible equipment issue. The model connects that visual evidence to a possible service interruption and recommends maintenance escalation. Finally, I test a standard text and table scenario. What is the main business issue in the operations performance report? This time, the system does not need image evidence. It uses text and table data from the operations report. The answer is based on the decline in performance and renewal rate values across the quarters. This gives me a clean comparison between standard text and table RAG and multimodal document RAG. One thing I want to be clear about: this demo shows a controlled, happy path. The documents are small, the images are clear. The visual conditions are intentionally easy to recognize. In production, this is not always the case. You may have blurry photos, poor lighting, ambiguous conditions, or image descriptions that are incomplete or incorrect. That is why a real implementation should log generated image descriptions during indexing, review samples, and validate the quality of the grounding data before trusting the system in production. With this video, I want to show one important point. An enterprise AI system should not rely only on text if the business evidence exists in visual content. If images are part of business documents, then images need to become part of the retrieval process. That completes this demo of controlled multimodal document RAG on Azure. In this project, we showed how business documents with text, tables, and images can be prepared for retrieval, indexed, and used to generate grounded answers with citations and trace. This demo focused on one important capability layer: multimodal document retrieval. In a larger architecture, this layer can work together with HyperRAG, MCP, Text-to-SQL, agents, and enterprise workflows. If you found this project useful, or if you have an idea for what my next AI architecture project should be, leave a comment below. I would like to hear what kind of enterprise AI scenario you think we should build next. See you in next video.